What is encryption? It's the process of scrambling plain text and converting the data to an unrecognizable or encrypted form. There are two types of encryption: symmetric and asymmetric encryption. Symmetric encryption uses one key for both encryption and decryption. Asymmetric encryption uses a pair of keys, a public key for encryption and a private key for decryption. Let's use the 101 blockchain encryption tool to understand symmetric encryption. So here's an auto-generated key containing 128 bits or 16 characters. Let's use the text hello to see the encrypted text. So I'll click the encrypt button, and you can see that it provided us with a scrambled text, which is the encrypted form of hello. Remember, this text was encrypted using the above key. You can send this encrypted text to anyone, and in order to decrypt it, they would need the same exact key. So let's try it. So I'll click the decrypt button, and you can see that it provided us with the original text, which was hello. Now, what would happen if we used a different key to decrypt it? So I'll go in and I'll change the last character of the key to a different character. From there, I'll press decrypt. And you can see that it was unable to give the decryption. It said decryption error, and it said that a bad key is used during decryption. Let's understand how this whole thing works. Let's take a look at this diagram explaining encryption and decryption. The most important components of symmetric encryption include the algorithm used for the process, the size of the key, and how you want to display the encrypted text. For our encryption tool, we used the AES, or the Advanced Encryption Standard algorithm. This algorithm is one of the most common algorithms, but there are many others. The key size that AES requires must be 128, 192, or 256 bits. These correspond to 16, 24, or 32 characters respectively. Any key size other than these three values will result in an error. Lastly, this tool uses base 64 encoding to display the encrypted text. As we saw in our tool example, when we provide a plain text, which is hello, and we encrypt it using this secret key, it converts this plain text into encrypted text. This encrypted text can only be understood if we decrypt it using the same exact secret key. Once we have decrypted it, it converts this encrypted text back to the original plain text, which is hello. So that explains encryption at a high level. Let's go back to the tool. Feel free to learn these concepts by interacting with the encryption tool and by changing the inputs and the key values.